So there's going to be like answer lines on the side of the page. You have to write your answer on the answer line. That's the only thing that counts right there, is your answer. It's either 0 or 2. So be very careful now. So where are we going to start? Again now. Oh. Let me think. You guys want test level kind or you want just simple kind?
Simple.
What? That's the wrong answer. I guess, okay, you want simple factor. N over n squared plus 1. Again, what is the limit? 0. You think you can see something like that? Yeah, you will, but it'll be like this. Okay, again. See, it makes the problem that much harder, right, when you do that. So yes, this goes to 0. So then now you gotta know what is cotan inverse 0. Again. Oh, now we know where the weakness is. Put plenty trigonometry on the test. Look, there's automatically going to be a lot. Take a guess.
Is it 0?
Well, cotangent of what angle is 0?
Oh wait, pi over 2.
Okay, pi over 2 is correct. How come when I say that you get it?
No, I mixed up tan and cotangent.
Okay, but there you go. Chan. Let me think of one. No, 3. Chan.
Pi over 4.
No. Well, what is this? What is the limit of that thing?
-1.
Okay, -1. So now you gotta know what is tan inverse -1. That's the problem. Trigonometry.
7 pi over 4.
No, because that's not in the range.
3 pi over 4.
That's not in the range either. Okay, I'll give you a hint. The range is from -pi over 2 to pi over 2. If the answer is not in between there, that it can't be the answer.
-pi over 4.
-pi over 4. C sub n. Okay, we just keep on going. Calabrese can. Just so we do. Just follow the same order we do when we play the game. Okay. illegal? Well, I will allow it, but just remember on the AP exam, we don't even, when we grade AP exam, D and E, we don't know what that means. Do not enter? We don't know, so that's why. On my test, you can put D and E, I'll allow it, but AP exam next year, no can, you know, unless you have a legend on your paper. Okay, keep on going. Good thing we're doing this. Woo! Oh, let's do this then. How about this? Next, Kimura. Cruz, did you go yet? Okay, it's Cruz's turn. See what you guys can, these aisles are just not in line there. See, I just put one little twist in it. Will that throw you off? Well, let me ask you this. Look at this. Doesn't that go to infinity? Right? So in other words, you have the graph of sine as it goes on, right? It just oscillates back and forth. So this also goes to infinity, right? So basically both of these are like the same problem then. It's just gonna oscillate back and forth, not getting closer to anything. So Cruz
Does not exist.
does not exist. You guys see why that's the same problem? Because this thing goes to infinity, that thing, they both go to infinity, except this one just goes to infinity slower, right? Remember, natural log is the slowest growing one? Yeah, okay. You guys don't like that one then. Okay, next. Okay, let me think. You got the good one. Okay, remember now, if you, maybe I shouldn't say if you know what the graph is, because maybe some of us don't know the graph. But if it's a base graph, just think of the graph outside.
Pi.
Yes. Of course, if I draw the graph for you, everybody in this room is gonna get it. These graphs have to be engraved in your brain. That's what the graph looks like, right? As the graph is going out to the right, what is it getting closer to? Zero. It's zero. Okay. Okay, tell me what to do. Maybe you can't do it in your head, but tell me what to do.
You look at the coefficients of n,
Okay, you can do that. So 1 over 1. So this goes to 1. But see then, this goes to infinity though. Remember now, do not go 1 to any power is 1. Because that's going to infinity. Like if it was 1, like if you had this, 1 to the second power, that's 1. But 1, you gotta remember, it's not 1 that's y. This is a number that's getting closer to 1. It's not 1. So that's why you cannot apply the same rules on this one. So this is the one where you have to massage, lomi lomi. You might even have to huli.
so I guess first huli. Are you huli first?
Okay, huli. Okay, and then?
And then massage it upon.
Wait, is this class, did I show you guys the video of lift and separate? Okay, we take a time out then. But, anyway, I never told you that story about lift and separate. What do you think lift and separate means? It means this, look, if you have A plus B over C, you can lift and separate. How did you guys learn it in Algebra 1? What did you guys call this? Okay, let's watch the video. Anyway, when I was a kid, I remember growing up, I was about 6 years old, watching watching a black and white television, YouTube. Okay. Playtex cross, or it's right there. Playtex cross your heart bra. Right here. This is the exact commercial I watched when I was a kid.
Now try this new way to accent your picture. Cross your heart. See? You're suddenly shaped there. Well, that's what this new Playtex Fashion Magic cotton bra does. It crosses your heart with stretch. To lift and separate.
Thank you.
Yo, Paul.
Now do you understand lift and separate? Never mind. Anyway, whenever I hear lift and separate, I always thought that from kindergarten, so I don't know what they're talking about on the commercial. Okay, so lift and separate. So what do we got? We got 1 minus 1 over n. Oh, wait, if we're gonna huli, we forgot to put the negative sign there, yeah? Don't forget to put the negative sign there. So lift and separate. Okay, now how do I lomi this to make it look like what it's supposed to look like?
So it's equal to e to the negative 1 or to the power of negative 2n.
Oh yeah, I forgot the 2 there. Okay, so first of all, we want this to be a plus sign, right? So put the negative in there. Okay, it's close. And then you just need n there. So you need to put the negative 2 outside the brackets, right? Because when you multiply the exponents, you get negative 2n. So what is the limit of the thing in the brackets?
E to the power of negative 1.
Okay, so e to the negative 1, but then all of that gets raised to the negative 2. So what do I put on the answer line?
E squared.
E squared is the answer. Anything else, 0. You're probably only going to get one of these now, unless you get 2. That's all I can say. Okay, we got more. So I can see what the weakness is. The weakness is base graphs and anything with trigonometry. Is that true? And we just got to do more. Hey, just wait till 2 chapters from now. The base graphs and it's going to come back again. Okay, what about, we just got to do these because they, yeah, I forget who's next. Right here? Okay, go. Think of the base graph.
Is it 0?
Wait, I'm thinking of the answer. No, I don't think it is. Now, of course, if I draw the graph, everybody in the room is going to get it. Okay, remember the range. What's the range for secant inverse? 0 to pi. See, then I remember the graph of secant and just switch the x and y's. I mean, that's the way I do it, but maybe everybody has their own way. Okay, as the graph is going out to the right, what is it getting closer to? See? These graphs gotta be, especially if you're going to BC. AB, like I said, we spent 3 weeks reviewing pre-calculus in AB. BC, you're expected to know everything when you walk into class the first day. Who's next? Kusumoto.
0.
What is it? I didn't hear. What was your first guess?
0.
Okay, that's correct. Everybody see why it's 0? N to the n FEPL. When both the top and the bottom both go to infinity, right? Doesn't this go to infinity? This goes to infinity. What happens when both of them go to infinity? You gotta figure out which one goes to infinity faster. So how do you classify this one? Logarithm. What is this? N to the first. Polynomial. Which one goes to infinity faster? Polynomial, right? Logarithm is the slowest growing one. That's the slowest. And what's the fastest growing one? N to the n is the fastest. So if the bottom is going to infinity faster than the top, the limit gotta be 0. If the top is going to infinity faster than the bottom, then the limit is infinity. N to the nth bubble, you can't make it easier than that. You guys gotta remember, n to the nth bubble. Oh! Okay, wait. Nah. How about square root of 10 over pi to the n? I just thought of that now. I should have saved that for the test. Okay, who's next? You. Okay, just tell me what your thinking is. When you have a number to the nth power, what do? It's geometric, right? A number to the nth power. Okay, this is review, because we're not going to do review when it's the next time we see you, Thursday, right? Because we go to the next chapter. Okay, so whenever you have a number to the nth power, you just got to figure out what this number is. If it's bigger than 1, the limit is infinity. If it's between -1 and 1, it's 0. And if it's smaller than -1, does not exist. So you just got to figure out what that number is. Here. It's a 50, well, that's a positive number, so it is a 50-50 chance, right? It can't be, doesn't exist. So you might as well guess, because it's all or nothing, right? Roll the dice, Liu. Does not exist, what? It's either 0 or infinity. Okay, well, let's see. What is pi? 3.14159, right? What is square root of 10? 3.162 about? Oh, you guys didn't know that one. Okay, well, now that I wrote it on the board, what? Which one is bigger, the top or the bottom? What? Who said bottom? 6 is bigger than 4. So if the top is bigger, this number is bigger than 1, just by a little bit. So therefore the answer is infinity. See, I told you in pre-calculus regular, they're just going to give you problems like this, 1.03 to the n. Come on, if we don't know that number is bigger than 1, go home, cook rice already, right? Oh, by the way, wasn't there a wrong answer, Tanaka? What problem? How come only one person per period one sent me an email? There was homework. Is that what you guys are thinking? 4? No, I don't even know. 1F. Let me see the problem. Yeah, 1F, the answer should be infinity. What did I put as the answer? Does not exist or something? Yeah, that's wrong. It should be infinity, so. Anyway. But then when I did the written solutions, I did it right. So, yeah, that's just a typo. I'm not going to change it, so somebody next year can get the bonus point. Oh, so you guys don't like these, eh? You don't like these. So let's do some more of those. Okay, I forget where we are now. Boom. Okay. Okay, let me think of a good one. Oh, wait. Oh, I'm thinking of some really good ones for the test right now. I don't want to use them up now. Do I? These are numbers you should be able to figure out. Okay, remember, didn't we have a problem natural log 2? What was natural log 2 about? Wang, right? You're the one who said it in physics, right?
0.692.
Okay, or 0.7, or less than 1. You should know that, right? So how can I, this is 1/2, Mr. Pro. Well, let's use our properties of logarithms. Say what? Okay, using your properties of isn't this the same thing as 2 to the -1? Moon, what can I do with the -1? Okay, put it in the front. So you got this now. And so if we know that this is 0.693, well, I hope we're 0.7 or something smaller than 1, then where does it fall? Here, or here? Wait. So negative 0.693, where would that be?
Zero.
Okay, 0 would be the answer. See, these are the kinds of problems. Okay, we're gonna do another one. Alright. Okay, let me think. Oh, cotangent 1. Didn't I give you tangent 1 on a worksheet, on a homework? I just chose to ignore that one, Mr. Park. Just gonna pray you don't give it on the test. They're all gonna be like this. Okay, if you don't know, just take a look. It's a 1 out of 3 chance when you have a number to the nth power. Okay, I'll give you a hint. This is 1 radian now, not 1 degree. What is 1 radian again? About what? 57.3 degrees, or just 57, less than 60. Okay, Mr. Park, I don't even know, no. Okay, here. What if you're on the SAT? Right? Because they do ask you to convert radians, right? Let's do some dimensional analysis. Radians, degrees. What do we know? 180 degrees is equal to pi radians, right? Isn't pi just a little bit bigger than 3? So what is 180 divided by 3? 60. So what would be 180 divided by something a little bit bigger than 3? It's going to be a little smaller than 60. You don't have to know 57.3 degrees. Something a little bit smaller than 60, I expect you to know. Okay, so on the unit circle, 57 degrees would be somewhere there. So again, you gotta reference it with something you know. Like, what is something we know about
45.
cotangent?
45.
45 degrees, right? What is the cotangent of 45 degrees?
1.
1. 57 degrees is bigger than 45. Okay, so now, make an educated guess here. No. If it was tangent, remember, tangent gets bigger as you go toward the y-axis, right? This is cotangent. So okay, think tangent. Tangent of 45 is 1. Tangent of 57.3 degrees is going to be bigger than 1. So if you have a number that's bigger than 1, what happens when you reciprocatize it? Like, you think of a number bigger than 1, 1.5. What happens when you reciprocatize it?
Smaller than
Now it's smaller than 1, and it's in the first quadrant, and it's positive, so what's the answer? 0. Okay, but see you guys, I'm not gonna be there telling you, okay, draw the unit circle, 57.3 degrees. You guys gotta think of that on your own. Okay, we gotta keep going, everybody's gonna get a 1. Sophie, wait, let me come up with the problem. I just had it. Wait, shh. I had it when I was talking about this, and then that's what happens when you get old, you forget things. I thought it was such a great problem. Oh, here it is. Sine, parentheses, 2n minus 1, in parentheses, pi over 2. Okay, sometimes, look, I don't know how to graph that. That's not a number to the nth power. So, sometimes you actually just gotta write out the terms. That's the only way you can tell. So you know they'll have at least one of these on there. Okay, Sophie, write out the first few terms. Like plug in 1, 2, 3, 4, and so forth.
Sine pi over 2.
Which is?
1.
Okay. Then plug in 2.
3 pi over 2 to negative 1.
Plug in 3.
5 pi over 2, which is 1.
Oh, of course, okay, so you got this. So what's the limit? Is it getting closer to anything?
No.
Okay, so mean girls? Huh?
Does not exist.
Does not exist. That's exactly correct. Hey, I'm not gonna be there with you guys when I take Mean Girls. This is Mean Girls. is it? Tanaka. Huh. Okay, both the top and the bottom are both going to infinity. So what's the tool I'm going to use here? N to the n FEPL. Okay, infinity. Because how do you classify factorial? Factorial. How do you classify that? Exponential. Which one goes to infinity faster? Factorial goes to infinity faster. So if the top is going to infinity faster, then it's infinity. You guys understand that? If the bottom goes to infinity faster, then it's 0. Wayne. Huh. Huh. Woo! Let me think of one. 9999999 to the n, all over n to the n. Okay, see? Easy. Right? This is exponential. This is n to the n. N to the n is the fastest growing function we know. So if the bottom is going to infinity faster, of course it's 0. And then we end with Wang. Okay, let me think of something out of No, moose bread. Maybe some of you can do it in your head. Or you can tell me what to write.
Is it 1 minus what? Sorry, I can't really.
Say that? What? What did you say?
Oh, I can't really see it.
What? You mean this is fourth quarter already? So on the first 3 quarters you couldn't see what I was writing
No,
on the
I
board?
can see the one above it.
Okay. Wait, this is the fourth quarter. Now can we see it?
Yeah.
Okay. Tell me what to write.
Is it close to 1?
Okay, this gets closer to 0. I agree, because the power on the bottom is bigger than the top. So 1 minus 0. So this gets closer to 1. But again, this goes to infinity.
Oh, so.
So you can't go 1 to any power is 1.
It goes to 0?
No. This is the E thing. The answer is gonna be E to the something. Remember that? You gotta massage, you gotta low me, you gotta even huli, but you don't have to huli on this one. You know what? Let me kick it up a notch just for that. I just thought of that. Take that. Wait, can you see that? Wait, no. There. I'll put a natural log in the front. Okay, but don't worry about the natural log for now. Just worry about this. That's just like, I just put that there to spice it up a little bit. Okay, so remember, we need this to be a plus sign, right? How do I make this a plus? Put the negative with the 3, like that. But then you just need n here. So what do I put outside the brackets? The 2, because then when you multiply the exponents, you get 2 to the n, right? See, I'm massaging it. Massage. Okay, so the thing in the brackets, what does that get closer to? 1 plus box over n to the n. Okay, here, limit as n approaches infinity of 1 plus box over n to the n is e to the box. Whatever you have here, that is the power of e. Okay, so this thing in the brackets gets closer to what?
E to the negative.
E to the negative. Okay, so the thing in the brackets gets closer to e to the negative 3. Therefore, the whole thing gets closer to natural log of e to the negative 6 then, right? So what answer do I put on the answer line? What's the only thing that's going to give me the 2 points?
6?
you know, whatever. Okay, I'm gonna use all of these problems then for periods 3 and 4. This is good. Why didn't, now don't worry, I haven't written the test yet, but when I sit down to compose, these will all be in my head. Anyway, these are no different from the problems that you had, right? Okay, so what we're gonna do today, we're gonna watch a video on fractals. Actually, I have the, what do you call it, the DVD for it, except,